All right, guys, today we are reviewing the number properties. We hit them last week a little bit, so we're going to go over them again today. So write down today's I can sentence. I can make or identify equivalent expressions. I can make or identify equivalent expressions. All right, the main idea behind equivalent expressions is where you have two expressions that will give you the same answer. For instance, 2x plus 3 plus x. And then the expression 4x plus 3 minus x. Right, these two expressions are actually equivalent. That means that they equal the same answer. Let me show you. If I put mine in boxes and I simplify this, which means make it as short as I can, here I have two x's and here I have another x. So that gives me a total of 3 x's. And then I just have that plus 3. I can't do anything with it. So that's as simple as I can get that one. Now I'm going to simplify the other one. So put it in boxes, plus out front. All right, this says 4 x's. All right, and here we have a minus x. All right, we know that a minus x gets rid of a plus x. So here I have 3 x's left. And then that plus 3 can't go with anything. So when I simplify those two expressions, they give me the same result, 3x plus 3, 3x plus 3, which means that those two expressions were equivalent. You don't know if they're equivalent yet until you simplify them. All right, let's go over these number properties again, because usually when we're making equivalent expressions, we have to use the number properties to do it. So we have 4 properties: the commutative, the associative, the identity, and the distributive. Okay. Now we have keywords for each one of those to try to help us remember what happens. The associative property changes the order of the numbers. So the commutative property changes the order of the numbers. The associative property changes what numbers are grouped, so groups. The identity property actually makes no change whatsoever. And the distributive property takes a number and shares it with everything else. All right, so let's look at quickly what these look like. For commutative property, let's say I have 3 plus x plus 7. Or maybe I have m times n times y. All right, remember the commutative property only works with adding or multiplying. So if I'm going to change this expression using the commutative property, I have to have my plus signs where they go. And all I'm going to do is take the same numbers involved and move them around. So maybe I put my 7 first, and then my 3, and then my x. Okay, remember that x is just like a blank. We just use variables now. So looking at this one, m and y, which actually, remember, means m times n times y. All right, if I'm going to change this using the commutative property, it has to all still be multiplying. I just switch around the ordered letters. So instead of m times n times y, maybe it's n times y times m. And there's lots of different ways you can do that. Associative property. All right, so maybe we have, 2 plus x plus 3, or maybe I have 3x times 2. All right, remember, associative property changes what is grouped. So this means that our numbers have to stay exactly where they are. The plus signs have to stay where they are. And the only thing that moves is the parentheses, changes what's grouped. So down here in the multiplying one, the numbers have to stay where they are. So it's still 3 times x times 2, but now I'm going to group the x and the 2. So I'm going to do x times 2 first. The identity property. The identity property has no change, and there's really only a couple ways this happens. The identity property is either plus 0 or times 1. So if I have, for example, 2t plus 0, well, that still gives me an answer of just 2t. Nothing changed there. If I take the same thing, 2t times 1, well, times 1 doesn't change anything. It's still 2t, or 2 times t. Nothing changes. Now, the distributive property is the one we're going to focus on today the most. Distributive property. It looks something like this. Let's say I have 3 times x plus 2. Okay. So the distributive property says you take this outside number and we share it with both of the inside numbers. We share it using multiplication. So what this ends up actually being is 3 times x and then 3 times 2, and put that plus sign in the middle. So now we can do a couple more things to this. For instance, I can do 3 times 2. I know that is 6. And I have my plus sign. And 3 times x, I can just rewrite as 3x. And there, I have now changed this expression into this. All right, using the distributive property. So right now it might be a good idea to screenshot this screen so you have this as a cheat sheet to use later on. Let's talk more about the distributive property. So let's go into example number 1. We're going to do a couple of these. All right, let's say I have 4 times 5 plus m. All right, this very much looks like the distributive property. Distributive property typically looks like some numbers in parentheses and one number on the outside. Now, do you see how that 4 is written right next to the parenthesis? That literally means that we're going to be multiplying. When something is written right next to it, it means multiply. In fact, there's a lot of different ways to show multiplying now. You could have, 4 times m means to multiply. 4m also means multiply those together. Soon we're going to be starting to talk about this. 4 times m, so in parentheses, those also mean to multiply. Or we could even have something like this, 3 times 2, if the 2 is in parentheses, that also means multiply. So all these things mean we're multiplying, and we're going to start looking at them more in those terms. So let's go back here. So we have 4 times, in parentheses, 5 plus m. So if we're using the distributive property, we have to share the 4 with the 5 using multiplying. So that becomes 4 times 5. And we have to share the 4 with the m. So that means 4 times m. And bring down that plus sign in the middle. Now we can do Aunt Sally. Well, there's not much we can do here. I mean, we can do 4 times 5, which is 20. Bring down our plus sign. No one told us what m is, so we can't change that. All we can do is say, okay, 4 times m could also be 4 times m, written like that. And that's our answer. That's as small as we can get it. We cannot put the 20 with the 4m. The 20 doesn't have an m in it, so they can't go together. All right, so this is as small as we can make that answer. So it started off as this, and using the distributive property, we simplified it to make this. This expression is equivalent to that expression. They mean the same thing, they just look different. Let's look at another one. Example number 2. Let's say I have Well, let's look at it backwards. What if I have 10 plus x times 6? All right, this is distributive property. I know that because I have a number on the outside and I have numbers in parentheses. All right, even since the number's at the end, that's okay. We can have the number at the end, it's no big deal. All right, so we're going to go ahead and distribute this. We're going to share the outside number with the two inside numbers. So share the 6 with the x, which literally means x times 6. Bring down your plus sign. Share the 6 with the 10, which means 10 times 6. And now we're going to do what we can, which in this case, we can do 10 times 6. That is 60. Keep the plus sign. And x times 6, I mean, no one told us what x is, so we can't change that. So it's just 6 times x, or 6x. I can just write it cleaner like that. That's my answer. That's as small as I can get it. I just changed this expression using the distributive property and made an equivalent expression as the answer. Example number 3. All right. You try this one. Try this one yourself. 5 times 7 plus r. All right, you try this one. Pause the video, do it yourself, and see what answer you get. Okay, you should have your answer now. So let's see how you did. This is distributive property because I have 5 times, in parentheses, 7 plus r. Let's share the 5. So 5 shared with the 7. It's 5 times 7. Bring down the plus sign. 5 shared with the r is 5 times r. Now let's do what we can. I can do 5 times 7. It's 35. I can bring down my plus sign. Nobody told me what number goes where the r is, so I don't care. So all I can do is rewrite it as 5 times r right next to each other. And I'm done. This expression, using the distributive property, turned into this expression. These two are equivalent. They will give you the same answer. Don't believe me? Well, let's pretend. Let's pretend someone walked into the room and said that r is the number 2. So my first one said 5 times 7 plus r. My second one, my answer, says 35 plus 5 times r. If someone walks into your world and said, hey, guess what? That r is the number 2. Let's make it the number 2. 5 times 2. So if I do Aunt Sally's business here, 7 plus 2 is 9. And I have 5 times that, and 5 times 9 is 45. Let's look over here. Here I have 5 times 2, which is 10. Bring down the plus and the 35. And 35 plus 10 is 45. They are equivalent. This expression gives you the same answer as this expression. That's why distributive property works. All right, here's a challenge one. Example number 4. And you have one like this on your homework worksheet this week. So let's see what happens. I know you learned a little bit about negative numbers. What if I have negative 2 times 6 minus m? Ooh, let's see how much you remember about negative numbers. Now, distributive property says share the negative 2. So negative 2 times 6. And then negative 2 times negative m. Well, a negative times a negative is a positive, so it ends up being 2 times m. The negatives cancel out. So it actually becomes a plus. So negative 2 times 6 is negative 12 plus, the most we can do there is 2 times m. That gives you your answer. Did I lose you there? Let me go over it one more time. Let me get rid of this here. Okay, see you again. Negative 2 times 6. And I'm going to share it over here. Negative 2 times negative m. Now, negative 2 times 6 is negative 12. A negative times a positive is negative. Negative 2 times negative m, well, the two negatives cancel each other out. They go away. They turn into just normal numbers. 2 times m, we can only say is 2m, because no one told us what m is. And it's a positive, because there's no more negatives. So this is what my answer looks like. That is a challenge question. We will be going over negative numbers here in a couple weeks. So don't freak out if you don't totally understand that. And make sure you ask me to go over that problem Friday in class from your homework worksheet. Okay, I think you're ready for your quick check quiz today. So go ahead and get on Schoology and take that, and good luck.